Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. The last two videos, we wrote our mutable singly linked list, and we finished off all the methods in the last video. However, we weren't able to test any of them. So in this video, I would like to put in some testing because I would hate to have the video show you code that winds up being fatally flawed in some way. And this also makes for a good excuse to show some more unit testing. So we come down here into our test ADT, and we'll make a new Scala class. What we call it test mutable SLL. And I am going to go ahead and open up one of our earlier tests just so that I can copy over the JUnit imports. Okay, I'm going to make a var that is the mutable SLL. Let's go of ints because they are easy to play with, and we'll import that. And before we run a test, we need to do okay. What is this unhappy about? Oh, I left out the keyword def because I put in the before and just forgot about the def. Okay, at test def, simplest test, just like we did with our stack, empty on create. Now, is empty, interesting just to point out that we can actually say assert true. If I could type it, we could. Assert true of lst.isEmpty. And you know, in some ways you might be like, whoa, we didn't write any isEmpty. This is true. However, the isEmpty is implemented as part of the buffer. So the fact that we have that, that we're extending the mutable buffer means that when we write these other methods, the however many methods it was that we had to write here, 1, 2, 3, 4, 5, 6, 7, 8, 9. We write these 9 methods. We implicitly get all of the methods that come along with this. Now, turns out the way that we wrote this right now isn't quite ideal for making it fit into the API, but the textbook has a section on how you can make it so that it really does the things that it's supposed to. I'll show you shortly what it does that's not quite the behavior that we'd like. So, if we run this test, our first test for, there we go, green bar, when we create it, it is empty, comes up being true, and the length is set to 0. At test def add 1. Okay, so I want to lst plus equals the number 5. Assert false. lst.isEmpty. Assert equals 1 lst.length. Okay, so this was doing an append, and if I run the test again, 2 tests pass. Okay, so that much works. At test def let's do add several here. LST plus equals 5 plus equals 7. Note, this is the reason why the plus equals returns the list object, is that way you can put them all together. We can also test out prepending. 1 plus equals colon 9 or 8 plus equals colon. So this should prepend the 1 and the 8 and then append the 5 and the 7. And I want to assert equals 4 is lst.length. I would also like to test the apply method. So assert equals 1 is lst sub 0. And then 8, 5, 7 for indexes 1, 2, and 3. We run the test. 3 tests pass, green bar. So far so good. So it looks like the prepend and append work. Now we didn't really, this isn't all that thorough of a test. This does test appending to an empty list. This tests prepending to an empty list because it's adding the 1 onto here first. So I feel pretty good about that. Ideally, you'd actually want to add some stuff and then remove it all and then add it all again. Hey, why don't we test that? Okay, so we'll add 3 things onto there. Check the length, and then assert equals lst dot remove at 0. Remember the remove, whoops, and I want to, that should return a 5. Remember the remove returns the data element that was removed. Then I'm going to remove the thing at 1, and lastly the remove thing at 0 again. So it starts off with 5, 7, 9. The remove 0 takes off the 5, so all we have is 7, 9. When I remove 1, which is not the first element, it takes off the 9, and then all we have left is the 7 to remove. And it would be nice to check to make sure that the removes are updating the size properly. And there we go. Okay, 4 tests, still a green bar. Okay, let's look at our code over here. We have tested append, we've tested prepend, we've tested apply to look up values. We've tested remove, we've tested length. We have not tested clear. At test, def, test clear. Let's add 4 things in there. Clear it, and then make sure that those 2 things pass. Bingo, 5 tests have passed. We haven't tested update. We need also to test the iterator and the insert all. Okay, so update. Test update. Let's go ahead again and make that list, and then lst sub 0 equals 99. Assert equals 99 comma lst sub 0. Also just um, 99 comma lst dot head, because that is a method that we should be getting. Now, to make sure we can set something other than, we'll put 98 in sub2, so that will overwrite the 5 with 98, and unfortunately that check I can't really do there. Okay, run the test again. 6 tests run, 6 tests pass. We still need to we did update, we need to do the iterator, and we need to do remove all. Test def test iterator, or not remove all, the insert all. So now if I have this, question is, how can I test this particular function here? So when I make an iterator, I guess one way I could do this would be to say val iter equals lst dot iterator, and assert false iter dot has assert true iter dot has next, assert equals 1 comma iter dot next, because that's what we should pull off. Copy, paste, paste, paste. Then we should have another one, it should be an 8, and we have another one, and it should be a 5, and we have another one, and it should be a 7. And at that point, that should be false. And we run it, 7 tests down, 7 tests in green bar. Okay, so only one test left, and that is the insert all. So how are we going to do the insert all? Well, we have to have something that we can traverse. Turns out this is a pretty darn easy test to do. In fact, what I will do, copy that test, paste it, and I'm just going to do one little thing here. LST plus equals 1, LST dot insert all at index 1, and the elements I want to add is a list of 8, 5, 7. Okay, so this should give me the exact same list that we had above. It should be 1, 8, 5, 7, and there we go. That's interesting. It tells me that it ran 1 test. Okay, there's all 8 tests. So all of these tests pass remarkably. All of this code appears to be working. These tests are not complete though. There are things that I have not put in a test for every single boundary condition. In this case, I would really like to actually insert all 2, where I don't do that, and at 0 I put in the 1. And there are quite a few other tests that you could come up with that just make sure that all of the boundaries are correct. But that's enough for this video, and we'll come back next time and we'll look at an alternate form of a linked list, the doubly linked list.